Okay, we're going to go over how to use the conversion factor method to perform unit conversions. Using conversion factors to change units may not seem like the easiest way, but will help you in the future when we learn stoichiometry. In order for us to change units without changing the value of the number, we must make the conversion factor, the units we want over the units we have, equal to 1. If the numerator and the denominator are equal, then the conversion factor equals 1. So it has to equal 1, otherwise we're changing the value of the number. And the whole point of a unit conversion is to change the way a number looks without changing the value. So this is how we do it. We go the number and the units given to us in the question, multiply by our conversion factor, so units we want over units we have. Then we fill in the numbers so that the top equals the bottom, and that's going to give us the units that we want. Units given, units have, same thing, so those would cancel. So start by writing down what you're trying to convert. Then draw your multiplication sign and the division line. Put the units you're trying to get rid of in the denominator of the conversion factor, and put the units you're trying to end up with in the numerator. And just a reminder, denominator is the bottom, numerator is the top. Fill in your numbers for the conversion factor. Remember, the numerator needs to equal the denominator. Okay, we're going to try some examples here. So convert 3,287.3 grams to kilograms. I want you, for these questions, I want you to be able to convert it without using a conversion factor. So just know that kilograms is 1,000 times bigger than grams. So you move your decimal over 3 places and you get 3.2873 kilograms. If we wanted to do this using the conversion factor method, we start by writing down the number and units given to us in the question, which is 3,287.3 grams. Then draw our multiplication sign and division line. We put the units we're trying to get rid of in the bottom, and the units we're trying to get rid of is grams. We don't want grams. And the units we want to end up with go on top, and that's our kilograms. And then we figure out what number can I put in the top and in the bottom so that the top equals the bottom. So you have to know the relationship between grams and kilograms, and that's actually given to you right over here. So 1,000 grams equals 1 kilogram. So we put 1 with the kilogram, because 1's with the kilogram here, and 1,000 with the grams. 1 kilogram equals 1,000 grams. The top equals the bottom, so this conversion factor essentially equals 1. So really all we're doing is multiplying by 1, which doesn't change the value of a number. So if you do this on your calculator, you take this, multiply by 1, divide by 1,000, and you'll get 3.2873, and then you put your units kilograms, because the grams cancels out. So that's how you do it using the conversion factor method. Here we have milliliters, we're trying to convert to liters. So again, liters is 1,000 times bigger than milliliters, so you can just move the decimal over 3 places, and you get 0.04338 liters. If you wanted to do this using the conversion factor method, you easily could. You just start by writing down the number and units given to you in the question, draw your multiplication sign and your division line. The units you're trying to get rid of go on the bottom, and the units that you want to end up with go on the top. And then you ask yourself, what numbers can I put so that the top equals the bottom? So we want to know how many milliliters equals how many liters, and I think that's this one here. I think this should be liters. So 1 milliliter equals 1 times 10 to the negative 3 liters. Also, you could do 1 liter equals 1,000 milliliters. Either of those is fine, but since this is the one given to us, we'll go with that. So 1 milliliter equals 1 times 10 to the power of negative 3 liters. Do this on your calculator. You take this times this, divide by this. and you'll get 0.04338. And don't forget your units of liters, because the milliliters cancels out. 3.12 hours, we're trying to change it to seconds. So this isn't one where you can just move the decimal like the other ones. You would have to use a conversion factor for this. Or if you knew like your hours and seconds, maybe you could just figure it out. But we're going to use a conversion factor. So we start by writing down the number and the units given to us in the question. So this is the number and units given to us in the question. Then we draw our multiplication sign and our division line. The units we're trying to get rid of, hours, goes on the bottom. The units we want to end up with, seconds, goes on top. And then we ask ourselves, how many seconds are in an hour? Now, if you don't know how many seconds are in an hour, you can easily figure it out. You know that there are 60 seconds in a minute, times by 60 minutes in an hour, which is 3,600 seconds in an hour. So 3,600 seconds in 1 hour. So our hours will cancel, and this one I actually do have to do on my calculator. So I go 3.12 times 3,600. And then you can go divide by 1, but 1s don't really change a number, so I just don't waste my time. So that gives me 11,232, and the units here is seconds. Now this one you should actually round to the proper number of significant figures. This is an exact number, so this has got infinity sig figs, and this one has 1, 2, 3 sig figs. So our final answer should have 3 sig figs. 1, 2, 3. So we want to cut the number off right there. So we go 1, 1, 2, but 112 is not the same as 11,232. So we have to put our 0 placeholders in there. Now we have 3 sig figs. It's approximately the same value as it was before. Put your units of seconds, and that's your final answer. Okay, and then we have one more example here. We're going from pounds to grams. This is definitely one I wouldn't be able to do in my head. I'd have to use a conversion factor. So start with the number and units given to you in the question. You might want to take a minute to pause the video and try this one on your own, but I'm going to just work through it right now. So 0.569 pounds, draw your multiplication sign and your division line. The units we're trying to get rid of, which is pounds, goes on the bottom. The units we want to end up with, grams, goes on top. And I have no idea how many pounds are in a gram. So then we'd have to go back and look at how many pounds are in a gram. So 1 pound equals 0.45359 kilograms.
To be returned right away, and any money that was collected, I need those by 2:30 this afternoon. That's all poppies and donation money. Please turn it in immediately. Thank you.
Sorry about that. So we can change this to grams just using our little decimal thing. So we know that kilograms is bigger than grams, so when we change it to grams it should be a higher number. So we move it 3 places and we get 453.59 grams, and that is equal to 1 pound. So 1 pound equals 453.59 grams. Now alternatively you could have done this using 2 conversion factors, 0.569 pounds. If you don't know how to do this conversion that I did over here, you can do just 2 conversion factors. We put pounds on the bottom, but since we can't get straight to grams, we go to kilograms first. And then in our next conversion factor, we get rid of the kilograms. We don't want kilograms anymore. We want to end up with grams. So then we would go 1 pound equals 0.45359 kilograms. And then we look at how our grams and kilograms relate using this conversion factor. So 1,000 grams equals 1 kilogram. So when I do this on my calculator, I go 0.569 times, if I'm doing the first one, 453.59, and then ones I just don't write. My calculator gives me 258.09271. I know I only want 3 sig figs though, because this number has 3, and I'm not going to worry about sig figs with this one. So 1, 2, 3, I cut the number off there, and that's where the decimal is, so that's a pretty easy one to round. And our units is grams because our pounds will cancel. If we were to do it the second way, you just go 0.569 times by 0.45359, which is right here, and then we would divide by 1, but you don't have to do that, and times by 1,000, and then again you could divide by 1, but you don't have to do the ones, and then we get the same answer, which is good. We should be getting the same answer. So you can do it either way depending on whether you know how to do this conversion or not. And here our pounds cancels and our kilograms cancels, and we're left with grams. So that's our final answer, or that's your final answer. So you should be able to do your unit conversion assignment now.